Hi, fellas. You're looking at a Chrysler FirePower engine, the latest thing in V-type overhead valve engines. And even if you're not working in a Chrysler dealership, I'm sure you want to know all about the FirePower engine. And, of course, you never can tell when a Chrysler owner is going to come in and call on you for help. You'll want to be able to take care of him. Now, that's Fred Lafferty over there. He's a service manager, and he's just returned from attending a Chrysler FirePower V8 engine school. Naturally, Fred is just busting with information. So, let's listen in.
Well, fellas, there's a lot that's new on the FirePower engine, and we can't cover all the features in one session. But just pop your questions, and we'll cover as much as we can.
One thing I'd like to know, Fred, is why the engine develops so much power and still gives such good gas mileage.
Well, that's due to a number of reasons. First of all, this engine has high thermal efficiency. That means how well an engine uses the heat energy available from combustion. You see, the energy that forces the piston down is really heat energy. So the more heat that's kept inside the combustion chamber and used, the more efficient the engine is.
Yeah, Fred. That's the big advantage of this hemispherical combustion chamber. It keeps the surface area as small as possible.
Right, Tech. So very little heat is lost through the chamber walls. Besides that, water circulates completely around each cylinder and over the combustion chamber, maintaining a more uniform temperature.
Yeah, and here's another important point. The spark plug is a resistor type 4S165 designed especially for this engine. Use that plug only, and you'll get the best performance.
Tech's right. That porcelain, for instance, contains a high percentage of aluminum oxide, like aircraft engine plugs. That means a stronger plug, one that resists heat better. You'll also notice that the side electrode doesn't completely cover the center electrode. That puts a sharp edge under a flat surface, which makes the spark jump the gap easier. The plug itself is located near the center of the combustion chamber. So the fuel mixture burns evenly and completely. That's because the flame has to travel only a short distance in the chamber. What's more, the flame travel expands evenly. The central location of the spark plug in the combustion chamber contributes to complete combustion. So you get full power from the burning of the fuel.
But that isn't the whole power story, Fred.
No, it isn't. The high power output is due first to its high thermal efficiency, and secondly, to its high volumetric efficiency.
Yeah, Larry. Volumetric efficiency is just a $50 term for good breathing. It means that the engine pulls in the maximum amount of air-fuel mixture and pushes exhaust out completely during each cycle.
Right, Tech. And the hemispherical combustion chamber in this cylinder head also contributes to good breathing. What's more, the hemispherical chambers are all smoothly machined for more accurate control of the high compression ratio, 7.5 to 1.
I catch, Fred. I noticed something else. That hemispherical shape gives more room to use larger valves.
Correct, Dan. And instead of in a straight line, the valves are on opposite sides of the chamber. Tell the boys about the valves, Fred.
Sure, Tech. Larger valves contribute to volumetric efficiency because they get that much more mixture in. Another thing, each valve has two springs, one inside the other. That prevents spring flutter and ensures positive valve closing.
I understand there's something else new, too. Aren't those rocker arms mounted on parallel shafts and pressure lubricated?
Correct, Larry. This valve arrangement also allows a practically unrestricted flow of mixture into the combustion chamber and an unrestricted flow of exhaust gases. Two other things that speed up that flow are the extremely wide opening of the valve ports and the high lift design of the camshaft. Besides that, the intake and exhaust passages have no sharp turns. The flow is practically straight through from carburetor to exhaust manifold.
What kind of gas does the engine use?
Well, Dan, this may surprise you, but in spite of the high compression ratio, the design of the combustion chamber lets us use regular grade gasoline and still get efficient performance.
That's true, Tech. Now, let's take up the matter of hydraulic tappets.
Oh, yeah, Fred. I understand we don't have to adjust those tappets.
That's right, Dan. These hydraulic tappets automatically hold the valves at zero lash.
Better give the boys more detail on that, Fred.
Okay, Tech. Each tappet assembly consists of a tappet body with a hydraulic unit inside. The plunger chamber is filled with oil from the engine oiling system. When the engine starts, the cam raises the tappet body. The column of oil under the plunger, being non-compressible, moves the plunger to lift the push rod and operate the valve.
Sounds good, but what about tappet servicing, Tech?
Well, foreign matter in the tappet will cause noise. In that case, you remove and clean or replace the tappet. Fred can tell you how to locate the noise.
Sure. You run the engine at idle with the cylinder head covers removed. Then press down on the push rod ends of the rocker arms until you find one that's noisy. If it's a slight noise, it'll get louder as you push down harder. But before you take the hydraulic unit up, make another quick check by using a hammer handle to put a side thrust on the valve spring. If this dampens the noise, it means that the valve stem's loose in its guide or the spring is cocked. Otherwise, it's a noisy tappet. So take out the tappet for inspection.
Yeah, and removing these tappets, fellas, calls for two special tools. This valve spring compressing tool and this valve tappet removing tool. Fred can show you how you use them.
Sure thing, Tech. First, slide the rocker arm away from the shaft bracket. Put the compressing tool over the arm with the heel of the tool resting on the valve stem side. Compress the valve spring enough to raise the rocker arm. This will free the push rod so you can move it to one side. Next, put the removing tool over the push rod and tappet plunger assembly. Slide the tool over the plunger spring and pull up the hydraulic unit slowly so the tappet body stays in the bore.
Take it easy, because if the tappet body comes out accidentally, you'll have to remove the intake manifold and tappet cover to reinstall it. Here's something else. Don't mix the tappet parts because they're matched sets. You can make or buy a rack to keep the parts in order.
Right, Tech. Now, fellas, you should take the hydraulic unit apart and clean it in commercial solvent. Then inspect it carefully for signs of wear. If the parts are worn or damaged, replace the unit. Otherwise, clean it thoroughly.
Yeah, and when new parts are removed from their wrapping, play it safe. Clean them with solvent and wipe them dry in soft, clean tissue. Don't go using an old, dirty rag.
Good point, Tech. Now, before you install a unit you've cleaned, push a small nail or wire through the inlet tube. This moves the check valve ball off its seat and releases any solvent trapped in the chamber. After that, use the special loading tool to draw a small amount of oil into the hydraulic unit. Then the tappet won't run dry when the engine is first started.
You use the same removing tool to install a push rod and hydraulic unit.
Then you position the rocker arm partially on the valve stem. With the compressing tool, squeeze the valve spring until you can slide the push rod into the rocker arm socket.
It about covers tappets. So let's turn this record over and talk about some other FirePower features and service tips.
Now, this engine also has very high mechanical efficiency. That means that there's less power loss due to friction. One reason that there's less friction is the short stroke, large bore design. The shorter stroke results in less piston travel, which cuts down piston speed.
I follow that, Fred. What else is new?
Well, the engine has 3-ring slipper-type pistons. The compression rings are very narrow, which reduces friction because there's less surface contact. Besides this, there are steel struts in the pistons, which control expansion better.
Yeah, Fred, and aren't the pistons accurately balanced?
Right, Dan. The weight of each piston is held within plus or minus 2 grams, regardless of size. They're held that close to keep the engine well balanced for smooth operation. Now, here's something else. The FirePower engine is short and compact. This permits the use of a short, rigid, and fully counterbalanced crankshaft. 5 large, precision-type main bearings support the crankshaft. This helps to cut down crankshaft deflection. A vibration damper mounted on the front end of the crankshaft cuts down torsional vibration. Oh, how about some other questions?
Okay, Fred. How do you get those spark plugs out of there?
Well, Larry, you probably know the cable covers come off first. And then you pull out the wires and porcelain insulators. After that, you use this special thin-wall, deep-socket wrench to remove the plugs. Then you just pull the sheet metal tube up, and the plug comes out with it.
Yeah, and the reason you use that special socket is so you won't break the porcelain. Now, Fred, suppose you explain spark plug installation.
Okay, Tech. Now, what you do, fellas, is invert this special socket and install the plug in it. Next, you put the metal tube over spark plug and socket, making sure the plug threads stick out of the tube. The tube acts as a gasket, so no gasket is needed. Now, holding these parts together, install the plug and tighten it to a torque of 32 foot-pounds. Then, replace the insulator wire and cover.
Now, Fred, how about explaining the two sets of breaker points in the distributor?
Okay, but I can show it better on the blackboard. Now, for example, one set of points is called the maker, the other, the breaker. Both sets of points are connected in parallel circuit and are individually grounded. This parallel setup means the spark won't occur until both points are open. Now, here's something else. The points are positioned on the mounting plate so that one set opens several degrees ahead of the other. When the maker points are closed, the breaker points are just starting to close. As the cam turns a little more, the maker points open. And since the breaker points are still closed, no spark occurs. But as the cam continues to turn, the breaker points open. And that's when you get the spark at the plug.
Nice going, Fred. Incidentally, fellas, this dual-point setup permits a greater buildup of voltage in the coil. That's because the primary circuit is closed longer than if you had only one set of points. As a result, there's a stronger spark at the plug.
I think I understand it now, Tech. What's the gap setting for those points?
15 to 18 thousandths, Dan, and it's got to be within those limits. Fred better give you the details.
Sure thing, Tech. You just loosen one of the stationary plate lock screws, Dan, so there's a very slight drag on the plate. Then you turn the distributor shaft until the rubbing block is on the high point of the cam. Next, you put a medium blade screwdriver in the triangle between the points. Turn the blade against the stationary plate until you get the right clearance.
After that, fellas, tighten the plate lock screw to hold that setting, but just the other set of points the same way.
I see. I suppose you adjust timing next.
That's the ticket, Larry, but it calls for a couple of special tools. How about starting with the timing light adapter, Fred?
Okay, Tech. I'll demonstrate that timing story. To begin with, you turn the engine over until the dead center mark on the damper lines up with the pointer on the chain case cover.
Okay, top dead center.
Next, you chalk this mark on the damper so you can read it better under the timing light. Following this, remove the number 1 spark plug wire from its tower in the distributor cap. That's the first tower counterclockwise from the clip closest to the coil. Put the male end of this timing light adapter in the tower and put the spark plug wire in the other end of this adapter. Then, you clip the blue wire of the timing light to the upper end of the adapter. Hook up the timing light black wire to the negative battery post and connect the red wire to the positive post.
I see, Fred. Then what?
Well, Dan, you hook up a reliable tachometer and start the engine. Let her warm up until she idles at 475 to 500 RPM.
By the way, remember to hold the accelerator 1/3 of the way down as you start the engine. This gives the right mixture for faster starting.
Right, Tech. Now, if timing's okay, the light will flash when the timing mark on the damper is opposite the pointer. If the timing isn't right, adjust the distributor position to bring the mark under the pointer.
I see. I suppose you adjust the carburetor next, eh, Fred?
Yeah, Larry. But let me point out what's new on that dual-throat type carburetor. Each throat, you know, feeds only 4 of the cylinders. Now, here's something else. The intake manifold passages are arranged so that each riser feeds the 2 end cylinders on one bank and the 2 center cylinders on the other bank.
In other words, fellas, the fuel passages are all about the same length, so the mixture is distributed evenly among the cylinders at all speeds.
Right, Tech. Now, the carburetor's also got a built-in automatic choke and 2 metering rods that are vacuum-operated, and a water-jacketed throttle body which maintains a more uniform temperature. This water jacket is particularly helpful in those areas where stalling may occur due to ice forming on the throttle valves. That may happen when the air is extremely humid and the temperature is between freezing and 55 degrees.
That's a good point, Fred. Now tell the boys how you adjust idle mixture with these 2 screws.
Okay, Tech. Before starting the engine, turn each idle screw clockwise until it seats. Then turn each screw back 1 full turn.
But take it easy. You can damage the taper on the ends of the screws if you run them in too hard.
Good point, Tech. Now, fellas, you start the engine and warm it up to normal operating temperature so the choke valve is wide open. Adjust idle speed 475 to 500 RPM. After this, turn each idle mixture screw the same amount until the engine runs smoothly. On the final setting, the screws should be within 1/8 turn of each other to produce the best engine operation.
Okay, Fred. I follow that now. I suppose you take the car out then and give her a good road test.
Yep, that winds up the stuff we've tried to cover. But remember, we've only hit the high points, fellas. There's a lot more ground to cover on FirePower engine features.
Fred's right, fellas. So this reference book is going to help. It's got more details on the engine and a good story on setting timing under special conditions. In addition, I'm going to come back later with even more information on this FirePower engine.